All right, so I am going to go over part three with you now. You should have already had part one and two done. So we'll go ahead and look at part three. And part three is mainly dealing with forces, right? And circular motion. All right, so fall semester exam part three. Disappear. All right, so number one says define and give the symbol for force, also can be called an applied force. So if we're just looking at that, we have F, which represents force. And if you want the applied force, you can write A like that. It's fine. Define and give the symbol for friction. If you're going to say it's like the force of friction, you can just write F of lowercase f for friction. Define and give the symbol for normal force. Normal force is F of lowercase n. Define and give the symbol for force of gravity. You can write F of lowercase g. Define and give the symbol for tension force. F of upper case T, capital T. Right? So these are the different types of forces that you could see whenever you're dealing with free body diagrams. And so if we wanted to define what these are, the applied force is the push or pull that's being applied to the object, right? When you're doing something to an object and you're trying to get it to change its motion, then it's going to be a push or a pull. That's the applied force. The force of friction is a force that opposes motion. It's a force that opposes motion. So if you are pushing something to the right, then the force of friction is going to be to the left, right? It always opposes motion. And then when we look at the normal force is the force that is perpendicular to the surface that the object is on. The object is on. And so if we were to actually draw that, if we had a box sitting on a table, right, we have the weight of the object or the force of gravity in this downward direction. And because this is the surface that the object is on, it's going to be perpendicular to that surface. And so your normal force would be in this upward direction like this, right? Number four says define and give the symbol for force of gravity. Here we've kind of drawn it out. The force is the force due to gravity. It's the force due to gravity. It's you can kind of look at this as the weight of the object, where weight is equal to mass times gravity. The tension force is the force in, let's see, it could be like a rope, string, chain, like a strap, like a backpack strap. I know there was a couple of questions that said that dealt with like holding onto a backpack, and if you were holding that strap, then you would have a tension force in those straps. In terms of inertia, what is Newton's first law of motion? Newton's first law of motion is inertia. And it states that, or the easiest way to look at that is saying that objects will continue to do what they are doing unless there is an unbalanced force. Okay, so objects will remain in motion, or objects at rest will remain at rest, and objects in motion will remain in motion unless acted upon by an unbalanced force. It's kind of a shortened version of that. Another way to look at it is inertia is the same as mass, where the more massive something is, the harder it is to get it to stop doing what it's doing, right? And that makes sense. If you had a small little pebble, there's not a lot of mass in that pebble, and it's easy to get it to stop what it's doing, right? If it's at rest, you could kick it and it'll go pretty far, right? The harder you kick it, the further it'll go. If you have a large, giant boulder, has more mass, more inertia, makes it harder to try to push that object, right? So inertia can be thought of as the same thing as mass. Okay? More massive objects are harder to change what it's doing. Less massive makes it easier. Inertia is the resistance to change in motion. In terms of acceleration, what is Newton's second law of motion? So acceleration can be defined like this. Newton's second law of motion can be defined as this. Acceleration is equal to force over mass. So we can state that two different ways, where acceleration is proportional. This is just a symbol for proportional. Is proportional to the force, the amount of force. And we can say that acceleration is inversely proportional to the mass of the object. Right? This just says that acceleration is proportional to force. This says acceleration is inversely proportional to mass. Another way to say that is that whatever happens to the force will happen to the acceleration. Right? So if you double force, what happens to acceleration? Doubles. If you decrease the force by half, then the acceleration is decreased by half. Right? So whatever happens with force happens to acceleration. Acceleration and mass are inversely proportional. So if you increase the mass, you decrease acceleration. Right? The opposite is occurring here. If you decrease mass, then you will increase the acceleration if you maintain the same force. What is Newton's third law of motion? Newton's third law of motion is your action, reaction forces. So for every action, there's an equal and opposite reaction, right? And so an example that we could give, right? An example would be if we did the action is hammer hits the nail, hits a nail that's going into a piece of wood. So the action is hammer hits the nail. The reaction would be what? Nail hits hammer. So one object is always doing the action, the other object is always doing the reaction. I know early on when we did this little example here, or talked about this example, the action, hopefully you don't think this anymore, hopefully you didn't think this. The action, this is what was thought early on, was the action was the hammer hits the nail, the reaction was the nail goes into the wood, but that's not what the reaction is. The action is the hammer hits the nail or applies a force to the nail. The reaction is the nail applies a force to the hammer or hits the hammer. Action, reaction. Number 9, under what two conditions will an object be at equilibrium? So equilibrium mean balanced forces, means balanced forces. And so two things can occur when you have balanced forces. When you have balanced forces, we're saying that acceleration is equal to 0. In other words, there is no acceleration when you have balanced forces. So two things occur when you have no acceleration. One, you can have a constant velocity, right? It's not speeding up, it's not slowing down, it's maintaining that velocity, it's not changing direction. The second thing that can occur if you have no acceleration is that the object could be at rest. So one of those two things could occur when you have balanced forces. Number 10, draw a free body diagram for a car driving at a constant speed. Include the 4 necessary forces with any made up magnitude and direction. All right, so for a car driving, I'm just going to draw a box. So if it's at a constant speed, right, we have a car driving down the road. What do we know that all objects are always going to have? The weight of the object, the force of gravity. What is the force that acts perpendicular to the object? I'm sorry, what is, the normal force? What do you know about these two forces here? They have to be equal and they have to be opposite. They have to balance each other out. They have to, because what did we say? It's at a constant speed. So if it's at a constant speed, right, or a constant velocity, what do we know about the forces? They have to be balanced forces. Or another way to look at it is if it's at a constant velocity, the acceleration has to be 0. Balanced forces. So these have to be equal and opposite. They have to balance each other out. The other thing is that you have an applied force. So the car is moving, let's say to the right. You have an applied force. The engine is applying that force. So it's moving to the right. But we also have to have a second force, or another force, I should say. This will be our fourth one. We have to have another force to balance that out. So we have to have the force of friction, and it has to be equal and opposite. Now, these that are on the vertical do not have to be equal to the ones on the horizontal. They just have to be equal to each other here. And when they do that, they'll balance each other out. Here, these don't have to be equal to these on the vertical. They just have to balance each other out. When that happens, you get the sum of all your forces to be 0. Okay. 11, draw a free body diagram for a car accelerating. So if we were to do pretty much the exact same thing here, right? Force of gravity, normal force, these two would balance each other out. Right? Those two would balance each other out. Here, if you have a car accelerating, you would have your applied force, and then you would have to draw your force of friction smaller than your applied force. Because these are equal, they balance out. Equal and opposite, they balance out. These do not balance out, and so the force that's larger, that's the direction that the acceleration will occur. Okay. Number 12, draw a free body diagram for an object at rest. This is easy. You have the force of gravity or the weight, and then you have the normal force in the upward direction. It's at rest, they should balance equal and opposite. Here we get into some actual calculations. What is the force needed? Force is equal to mass times acceleration. So here's the mass, so 0.43 kilograms. The acceleration is 2 meters per second. So if we multiply that out, you should get a force of 0.86 newtons. All right, just a few more. Turn over on the back side. Box is sliding horizontally across the floor shown below. Use the image to answer the next few questions. What is a net force acting on the object? Newtons allows us to know that those numbers, the newtons here allow us to know that we're dealing with force. So we don't have to calculate force. We already know it. But now we get the net force. So we have to take the sum of these forces. So if they're opposite of each other, we're going to subtract. So we do 20 minus 10. So the net force is 10 newtons, right? We're doing 20 minus 10. We also need to know the direction. So it'd be 10 newtons to the right. What is the horizontal acceleration of the box? If we know the net force, then we can get the acceleration. Acceleration is the sum of all the forces, or the net force over mass. And so we're going to use this net force that we solved for here. We're going to plug that in. We know the mass is what, 50 kilograms? So if we do 10 divided by 50 or 1 divided by 5, we get what? 0.2 meters per second squared. Okay. What is the weight of the box? Weight is equal to mass times gravity. If we want to know what the weight is, we take the mass, which is 50 kilograms, multiply that times gravity, 10 is good enough. So it's going to be around 500 newtons. I think if you use, if you use 90.8 or 490. What is the normal force of the box? If it's on a flat horizontal surface, I told you that the weight will equal the normal force. So the normal force would be 500 newtons. If the weight is 500, then the normal is 500. It's because it's not on an incline. If it was on an incline, we would have to do some more calculations, use a little bit of trigonometry to be able to solve for that. Could we? Yes. Are we going to? No. It's on a flat horizontal surface. And then the last one, or last couple of questions here. Draw and label the vectors that show the direction for centripetal force and velocity. So we're saying that the object is moving in a counterclockwise circle. Centripetal means center seeking. So if we draw the force, it would be an arrow that's pointing to the center of that circle. That would be F sub C. And then for velocity, this is tangential velocity. A tangent line is a line that passes through only one point of that circle. And so if that's where the object is, then your tangential. What's that? That's F sub C for centripetal force. The next one, law of gravitation, describes the attractive or repulsive force between two objects. So if it's gravity, gravity is always going to be what type of a force? An attractive force, right? Gravity is always pulling everything towards the ground. At no time does gravity ever eject anything out into space. Right? Gravity pulls everything towards the center of mass. So for the Earth, the center of mass, everything pulls down towards the ground. What happens to the force? The force blank if the mass of one or both objects increase. So if the mass increases, force will increase. The force increases if the objects get bigger. And then the force blank if the distance between the objects increases. So if the objects get further away from each other, then that means the force is going to decrease. The objects experience more force if they're larger and closer together. They experience less force if the objects are smaller and further apart. Okay. And that was part 3 for your semester exam review.